Alright guys, so this video is going to be about what we've learned last week, including a little bit of this week. We're actually reviewing what we did this week. Let's close this off. Alright, so here is our periodic table. This is the same one that you will be utilizing on STAR. And we're going to start with just some basic things. So we know that all of our metals are to the left. Alright. Our metalloids are right here along the staircase. And then our non-metals are right here. Okay? So we already know that. We don't really deal with this middle section. These are the transition metals. So as I've shown you before, if you want to, you can just make a fold wherever boron is. And then if you fold that to meet beryllium, these are the only elements you're really going to be focusing on STAR. Now it may ask you to calculate protons, neutrons, and electrons for these elements, but when we're dealing with the periodic table, we really focus on just these 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So if you don't remember that 13 is 3, always focus on 3A. So I'm just going to put a box around those. So these are our groups. Groups go up and down or vertical. And we have 8 groups. And our periods are right here. So we have 7 periods just like we have 7 class periods a day. So now I'm going to just make a few notes to help us remember what they tell us. So the periods tell us the number of shells or energy levels or orbits. All of those words can be used interchangeably. So this entire row has 1 shell. I'm going to put 1 circle around 1. This entire row has 2 shells. This one has 3, 4, 5. Sorry, it's getting a little tight here. Then 6. And then the last one is 7. Alright. So as you go down a period, you notice that the atomic number is increasing, and also the atomic radius, or the length from here to here. Alright, you guys learn radius in math. So the period tells us the number of shells, orbitals, or energy levels, though all of those words are the same. And then the numbers at the top that have the box, those tell us how many valence electrons. So let me try to get it to focus here. Alright. Alright. So for example, here is calcium. Calcium is in group 2 right here, which means it has 2 valence electrons, and it is in period 4, meaning that it has 4 shells around its nucleus. Boron. Boron is in group 3A, which means it has 3 valence electrons. It can also be considered in group 13, and it is in period 2. Alright? It is in period 2. So that means that boron has 2 shells around its nucleus, and it has 3 valence electrons. So we already learned that valence electrons are the electrons that are in the outermost shell. So just for a reference, this is the activity that we did today. All of these are, let's see, come on, focus. There it is. Okay. All of these are electrons, all 9 of them, but only these are the valence electrons. They're the ones on the outermost shell. So although this atom has 9 electrons, it only has 7 valence electrons, only 7 on the outermost shell. Okay? So back to our periodic table. We've been working on identifying elements based upon the group and the period, and we also incorporated reactivity. So our 2 most reactive groups are 1 and 7. So I'm just going to put reactive here. And then our group 8, we call this group inert or non-reactive. This group has, almost all of them except helium, this group has 8 valence electrons. And our rule for electrons is 288. So because this row has a full shell, it does not react. All right? It's not going to react because it already has a full shell. Now helium, on the other hand, helium's atomic number is 2, and we learned in 8-man atomic number equals protons equals electrons. So if my atomic number is 2, that means that helium has 2 valence electrons. And we already learned that the max electrons for the first shell is 2. All right? See you later. All right. So here we go. 2. Just like this. This one also, you can see that it only has 2. So 2 goes into the first shell. Same here. The first shell here only has 2, and this shell has 1 because it is atomic number 1. So helium actually has a full shell for the first shell, just like this. So helium is going to be non-reactive. All right. So all of these have 8 except helium, which is going to have 2 because it has 2 electrons total. So 2 electrons total means it has to have 2 valence electrons. It can't have 8. It is in this group because it behaves just like a gas. It is not going to react with anything. All right? So let's look at some practice that we've been doing throughout the week. So this is the activity that we did on Friday, and we had to use our periodic table. We're just finding the basic information for protons, neutrons, electrons, protons, group, period, and valence electrons. So for A, which is sodium, we're going to be writing that information here. For B, it is atomic number 13 because we know that A equals P equals E from 8-man from last semester. The atomic number is equal to the protons, which is equal to the electrons, or you can count the electrons. And then we have to find the metal, third period, second group. And we already identified our metals, nonmetals, and metalloids using our foldable from last week. So we color them red, blue, and purple. So here's sodium. Sodium is right here. Its atomic number is 11, so I'm just going to write the element name here, sodium. How many protons does sodium have? Well, the atomic number is 11, meaning that sodium has 11 protons. What group is it in? So groups are at the top, vertical. Sodium is in group 1, which means it has 1 valence electron, 1 electron in its outer shell. And the period is 3, which means it has 3 rows. So I'll show you just to make sure that you're understanding the valence electrons. I'm going to draw the Bohr model for sodium. So I have to start with my subatomic particles, which we learned how to count last semester. The atomic number is 11, which means I have 11 protons, 11 electrons. A equals P equals E. The mass of sodium, remember the atomic mass is at the bottom and it has to be a whole number. So 22.9 becomes 23. And we have 23 minus 11 to get our number of neutrons. So 2 and 1. which means it has 12 neutrons. So now let me draw the model to prove that it has 1 valence electron and 3 orbitals. So here's my nucleus. I'm just going to put 11 proton and 12 neutrons. Here's my first shell, and I need both electrons here. It can only hold 2. Here's my second shell, and the max that I can hold is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is 10, but sodium has 11. So I have to go to the next shell, and there is my 1 valence electron. And I've utilized 3 orbitals, or 3 shells. Okay? So that's exactly what I'm referring to when I mention shells, energy levels, and then valence electrons. Okay? So I'll finish out this set. So element B, I don't even need my periodic table, or only for the name. We've dealt with this one before, so we know that this is aluminum, and it's right here. So I'll write aluminum. It has 13 protons, and I know that it's in group 3 because I can count the valence electrons. 1, 2, 3. I'm in group 3. Or your periodic table, here is aluminum, if it focuses. Okay, here is aluminum. It's in group 3, and it is in period 3 as well. Or you can look at the shells. 1, 2, 3. All right, it's in period 3. Valence electrons, 1, 2, 3. And last one, I am a metal. I am in the 3rd period and 2nd group. So 3rd period, we know we only have 7, so it has to be here. And I'm in the 2nd group. Well, here's group 2, magnesium. Okay? All right. So this one is going to be magnesium. Magnesium's atomic number is 12, so it has 12 protons. And it already told me it was in the 2nd group. It's in the 3rd period, which means it has to have 2 valence electrons. Okay? Now, which one is the most reactive here? So we already know that groups 1 and 7 are the most reactive. The closer we get to francium for metals, and the closest we get to helium for nonmetals. So these are all metals. Sodium is in group 1, so sodium is going to be the most reactive. So I have the chemical symbol and the name. Okay? And then we did a very similar activity, which is the Who Am I, where you have to identify the elements based upon the clues. So this is pretty much everything with groups, periods, and valence electrons all together. We've done this one already as well. So my main focus is just you understanding the periodic table, the groups, the periods, and then the reactivity. So the closer you get to francium, the more reactive you are for metals, and the closer you get to helium, the more reactive you are for nonmetals. Another word for non-reactive, we keep on asking the same question, is inert. Inert just simply means not reactive.